Welcome back to Nick's Algebra X. So today we're going to talk about the different properties of numbers that you've been using throughout your whole life. So before we get into that, we have to talk about equivalent expressions. So equivalent expressions are expressions that are the same. It's literally in the word, equivalent expressions. They're expressions that are equivalent because they represent the same number. Although they might not look like they do, they really do. For example, 2x plus 3x equals 5x. So 5x and 2x plus 3x are equivalent expressions because they represent the same number. And the properties that we're going to talk about in this lesson are going to allow you to write equivalent expressions for a given expression. So let's start with one of the most obvious properties is the reflexive property. And what that says is any quantity is equal to itself. So basically, x equals x. It's super obvious. So using numbers, that would be something like 3 equals 3, or 3 plus 2 equals 3 plus 2, because they both equal 5. Another property is a symmetric property, which is kind of similar to the reflexive property. It says that if one quantity equals the second quantity, then the second quantity equals the first. So basically, if x equals y, then y equals x. So if 3 plus 2 equals 5, then 5 equals 3 plus 2. And then there's the transitive property. So the transitive property takes this one step further. It says that if one quantity equals a second quantity, and the second quantity equals a third quantity, then the first quantity equals the third quantity. So basically, that says that if A equals B, and B equals C, then A equals C. So for example, we can say that 3 plus 2 equals 4 plus 1. And we know that 4 plus 1 equals 5. So therefore, we know that 3 plus 2 equals 5. Because as we can see, A equals B, and we know that B equals C. So therefore, A equals C. Because this is A, and it equals C. And then another property is the substitution property, which says that a quantity may be substituted for its equal in any expression. So if A equals B, then A may be replaced by B in any expression. So for example, if A equals 4, then 4A equals 4 times 4. Because A and 4 are the same thing, so I could substitute 4 for A, and you'll get that 4 times 4 is 16. So some more properties are multiplicative identity. So that says that the product of x and 1 is x. So basically, x times 1 equals x. And you could also write this as 1 times x equals x. So an example of this would be like 7 times 1 equals 7. Or 1 times 7 equals 7. Because it's in the word identity. We're maintaining the same identity. And to maintain the same identity, we could just multiply by 1. For the additive identity, to maintain the same identity for addition, we have to just add 0. Because the sum of x and 0 is x. So x plus 0 equals x. and 0 plus x also equals x. So for example, x could equal 7, so 7 plus 0 equals 7, and 0 plus 7 equals 7. So for multiplication, to maintain the same identity, we multiply by 1, and for addition, we add 0 to keep the same identity. Now, the multiplicative property of 0 says that the product of x and 0 is 0. So that means that x times 0 equals 0, and 0 times x also equals 0. So using numbers, using the number 7, we could say that 7 times 0 equals 0, and 0 times 7 also equals 0. So if you want to kill a number and just make it 0, you use this property. Now the next property is the multiplicative inverse, also known as reciprocal. So when you see the word inverse, that means we're undoing an operation. And we can undo something using the reciprocal. So for every number x over y, there is exactly one number y over x such that the product of x over y and y over x is 1. So that means that x over y times y over x equals 1. And y over x times x over y, if you switch these, also equals 1. So using some numbers like 3 over 5, we can multiply by the multiplicative inverse, also known as the reciprocal, which is 5 over 3. And that's going to equal 15 over 15, since 5 times 3 is 15, which equals 1. And you could do the same thing the other way around, and you'll still get 15 over 15, which equals 1. So multiplicative inverses undo it and make it back to 1. Now for additive inverse, to undo addition, we have to add the opposite number. So a number and its opposite are additive inverses of each other. So if I have x, I could add negative x to it, and now undo it and make it 0. This is the same thing as just subtracting x. So that's like 7 plus negative 7 is 0. Or 3 minus 3, that's 0. In multiplication, to undo it, we're multiplying by the reciprocal to make it 1, and for addition, to undo it, we're adding the opposite number. So let's do an example. So let's evaluate this and name the property we used in each step. So first we're going to start off with what's in the parentheses, which is 4 minus 3. And we know that 4 minus 3 equals 1. And the property we used there was substitution, because we substituted 1 for 4 minus 3. So next, we're going to do what's right next to the 1, which is 7. So 7 times 1 is 7. And by multiplying by 1, we're keeping the same identity for 7. So this is the multiplicative identity. So next, we're going to multiply 5 and 1/5 together. And 1/5 is the multiplicative inverse of 5, because 5 over 1 and 1 over 5 are flipped. So that's going to just equal 1, because that equals 5 over 5. So that's multiplicative inverse. So now that it's all subtraction and addition, we're going to solve it from left to right. So 7 minus 1 is 6, and 6 plus 1 is 7. And the steps we used for all that is substitution, because we substituted 6 for 7 minus 1, and we substituted 7 for 6 plus 1. So here are some more properties. So the commutative property of addition and multiplication say that the order in which you add or multiply numbers doesn't change their sum or product. So basically, a plus b equals b plus a, and a times b equals b times a, because the order doesn't matter in which you add or multiply. So an example of this would be like 3 plus 2 equals 2 plus 3, because they both equal 5. And you could also say that 3 times 2 equals 2 times 3, because they both equal 6. Now, the associative property of addition and multiplication say that the way you group 3 or more numbers when adding or multiplying doesn't change their sum or product. So that basically says that a plus b plus c equals a plus b plus c. And same thing for multiplication. A b times c equals a times bc. So basically we're just moving the parentheses. And for addition and multiplication, it still equals the same thing. So for example, 3 plus 2 plus 1 equals 3 plus 2 plus 1. Even when you shift the parentheses, it still equals 6. And same thing with multiplication. 3 times 2 times 1 equals 3 times 2 times 1, because they both equal 6. So let's do an example. Let's evaluate this using the properties of numbers we just learned, and let's name the property in each step. So instead of doing this from left to right, we're going to do it another way, because when you work from left to right, you're going to get that 5 times 7 is 35, and you multiply that by 4 and 2, and that takes a while to solve, but we could do this a much easier way. So what we can do is we could rearrange this into 5 times 2 times 7 times 4 using the commutative property, because the order in which you multiply or add doesn't matter. And then we're going to put parentheses around them using the associative property, which I'm not going to abbreviate for reasons. So now it's easier and faster to solve. So 5 times 2 is 10, and 7 times 4 is 28. So we use substitution there, because we substituted 10 for 5 times 2 and 28 for 7 times 4. And multiplying by 10 is really easy, because you just added 0. So 10 times 28 is 280. And that's substitution as well, because we substituted 280 for 10 times 28. And that's it for today's video. So those properties were really obvious and really easy, and you're going to use them a lot throughout algebra. There are more properties than this, and we'll talk about them in future videos. So I'll post a worksheet with the solutions, and don't forget to subscribe, comment down below, like the video, and turn on your notifications. I'll see you soon.